Alright, and here we are at the bottom of page 3. We're in section 1.2, page 3 of the notes, just for a reminder. And the instructions are actually at the top of your notes page. I'll read them for you. Perform the indicated operation. Reduced to lowest terms. So we just need to pay attention to what they're asking us to do, and you can see the difference here is they're asking us to divide in both the example and the try problem here. So we're going to be able to divide, and the wonderful thing about dividing fractions is you actually get to make one adjustment and then it turns into a multiplication problem. So we are going to flip the second fraction and multiply. And it's very important that you flip the second fraction, not the first. So there's not a new skill here, it's just a little reminder. Now this is one of those things where math takes that turn from it all maybe making sense and then this random sounding rule throws in. You got to remember, the rule comes from a pattern that was seen over and over with numbers. Now, it's not our place really to explain it in Math 60. Hopefully you had a great fraction teacher either in Math 20 before this or whatever your background is before you came to Math 60. But if not, there's this quick little, it's not a proof necessarily, because proof, you need to do those without numbers. You need to do it in general terms. But why do you flip the second fraction and multiply? Well, think about this. If I had, let's say 6 of something, and I wanted to divide it by 2, that would equal 3. Okay? Some might even say, oh, I'm just cutting that in half. That's exactly right. That's the same thing you would get if you did 6 times 1/2. Well, notice that that also equals 3. Notice that the division becomes multiplication and 2 becomes 1/2. What is that? Well, 2 is equal to 2 over 1, and flipped, that's equal to 1/2. So to divide is the same as if you multiplied by the reciprocal or the inverse. Okay? So the flip is really to use the reciprocal or the inverse of it. Just a little background on why. Now that, again, this is not an official proof because we're using numbers, and the cynic out there might say, oh, well, 6 divided, that works for 6 and 2 and 3, but what about other numbers? How are we guaranteed that it's always going to work? And we could go through a full elaborate proof, but again, that's not our place in Math 60. I'm happy to do it for you outside of class. Come see me during club, and I will put all your fears, I'll calm all your fears on that, answer all your questions, we'll get you squared away. You'll be able to rest easy from here on knowing that's why we flip and divide, how we can prove that. Okay, but in the meantime, we'll go ahead and apply this rule. We've got 3/7 divided by 1/7, which means we're going to take that 3/7 and we're going to multiply by 7 over 1. So now we're multiplying. First we were dividing, and we're dividing by the reciprocal. And again, before we multiply it all out and then try to reduce, we're going to go ahead and look at what we have first of all. And what we have is 3 times 7 on the top, 7 times 1 on the bottom, which when you have all multiplication top and bottom, you're looking for things that will cancel, same exact matching factors. And the reason why is because what we're not showing here in this step is that can be rewritten as 7 over 7 times 3 over 1. That would get you the same result. Multiplication can be switched around. 3 times 7 is the same as 7 times 3. And then 7 over 7 can be pulled out, and that's really just equal to 1 times 3 over 1. 7 over 7 is a way of just describing a whole pie. It's 1. And then that, of course, just gives you 3 over 1, or just plain 3. So in this case, you can cancel these, and you'll see the 3 over 1 right here. that we got all the way at the end, or you can think of it all the way through. But the 7's cancel, you're left with 3 over 1, or just 3. So talk that through, tell somebody about it, tell yourself, know any questions you might have, decide if you're going to come see me about, okay, I'm not totally convinced, show me again, how does that work with the flipping and the multiplying by the reciprocal. And then pause the video so you can try number 62. Okay, if you haven't had a chance to try number 62, pause the video now because I'm going to reveal the answer. When you divide 7/4 divided by 3/8, you should end up with 14/3, that's the improper fraction version, or you could write it as a mixed number, 4 and 2/3. Page 21 gives you a chance to see how the book phrases it, talking about dividing fractions. The quotient of two fractions, that's the answer you get when you divide. First fraction multiplied by the reciprocal of the second fraction, and then they show it in algebraic language. A over b divided by c over d equals a over b times d over c. You've got the same first fraction, a over b. You've got division, and then it changes to multiplication, and then c over d flips to becomes d over c. They even use the word invert there for the inverse. And that takes care of page 3.